Okay, this is going to be part 8 of the video series on trigonometric substitution. And in part 7, we did a substitution problem where you had to complete the square. But in that problem, the x squared term was positive. Now let's take a look at a similar problem. We'll have to complete the square again, but in this problem, the x squared term will be negative, and it'll change how you have to go about the problem just a little bit. Now we're still going to use the same steps that we've done before. So if you need to, watch the previous videos in this series and it'll show you where this series of steps comes from. But let's take a look at that series of steps right now. So what we've got is this. Now remember, we added this 0 step. If necessary, complete the square to put it in the form of something squared plus something squared or something squared minus something squared. So in this problem, we're going to have to do that. So the very first step here will be to complete the square. So let's just go ahead and do that on this problem. So this is going to be step number 0. So step 0 is to complete the square. So step 0. Now to do that, take what's inside the square root, and we'll go ahead and just use the algebraic technique of completing the square. And most of you guys should have done that back during your algebra days. So let's run through this. So first of all, take what's in the square root, minus 8x minus x squared. Now, all you want to do is complete the square on this. So first of all, take everything but the 9 and move it over to this other side. And that would give you x squared plus 8x. And then leave a little space, and this is going to be equal to a 9 on this side. Now remember, to complete the square, since you've got a 1 in front of the x squared, take whatever's in front of the x and divide it by 2. And I'm assuming here that you remember the technique for completing the square. So you'll have 8 divided by 2 would give you a 4. And then take the 4 and square it. So 4 squared would give you 16. And then you take the 16 and you add it to both sides. So we'll add a 16 to this side. And to make up for that, we'll go ahead and add a 16 on this side. So add a 16 to both sides. So you add it to there and to there. Now that will allow you to write as something squared. So what would be x, and again, this whatever's in this circle will be inside the parentheses. So x plus 4 squared is equal to, and then add these two together, and you get a 25. Now we want to change it back where you just have a 0 on this side. So take this and move it over to this side, and you'd have 0 is equal to 25 minus x plus 4 squared. And now you've got it in something squared minus something squared form. So you've completed the square, and that will allow you to rewrite the problem. So let's go ahead and do that. And we'll rewrite this thing as the following. It'll be equal to the integral of, so and we'll start right here. Here's dx. Now you still got the x on top, and we'll write it as the square root of, and all we're going to do is change it from this form into this completing the square form. So this is going to be 25 minus x plus 4 squared. Okay, so what that does, you've got it in the form of something squared minus something squared. Now again, just a reminder, you can kind of think of this as being, think of 25 as being 5 squared minus x plus 4 squared. So the way we've got it set up here, this is going to be equal to our a, and this is going to be equal to u, the way we set up the formula. So now we've got it in the right form, we're ready to go back to the steps and move on to the next step. And the next step says the following. First of all, determine which of the 3 forms that you have it in. So again, let's just a reminder on what the forms look like. We had 3 cases. Remember, it could be a squared minus u squared, a squared plus u squared, or u squared minus a squared. Now looking at our problem, what we've got is an a squared minus a u squared. So this is going to be a case 1 problem, a squared minus u squared, and you'll use these 2 equations right here. So you can just forget about these other ones and really just concentrate on this. So when you change the square root, you'll use a times the cosine. When you use u, you use a times the sine. So those will be the 2 formulas that we'll use. So now back to our problem. Okay, let's go ahead and put those formulas up here just where we can see them. So the way we've got it, the square root will be a times the cosine, u will be equal to this. And now it's just a matter of running through the remainder of the steps. So let's go ahead and do that. Let's take a look at the next one. It says, now you've got to change it from a problem in terms of x into a problem in terms of theta. So first of all, you got to change the square root, then you'll change the dx, then you'll change any remaining x's. So we'll take care of step 2 first. So on step 2, and we'll do it in red like we've done in the other problems. So step 2 says the square root of 5 squared minus x plus 4 squared is going to be equal to, and you can set it equal to a times the cosine of theta. So a times the cosine of theta. So that gets you to this. 5 squared minus x plus 4 squared is equal to, now a is equal to 5, so you'd have 5 times the cosine of theta. So you've got your first part of the conversion right there. That takes care of the square root. So let's look at the next step. The next step says now take care of the dx. So to take care of the dx, you need to begin with this u here. So this will be step number 3. So what step 3 says is starting with u is equal to a times the sine of theta. Now replace each one with what it's equal to. So u is equal to x plus 4. So I'll have an x plus 4 here. And that's equal to a, which is 5, times the sine of theta. Well, now you need dx, so go ahead and solve this thing for x. So move the 4 to this other side, and you'd have x would be equal to 5 times the sine of theta minus 4. But you need the derivative of x, so we'll take the derivative of x with respect to theta would be equal to 5. Now, just a reminder, the derivative of the sine is the cosine. And the derivative of a constant goes to 0. So this gets you to the differential x would be equal to 5 times the cosine of theta d theta. And there is dx. So you'll use what's in this little box to change dx into d theta. Now let's look at step 4. So step 4 says express any remaining x's in terms of theta. So let's go back to our problem. Now in our problem, the only remaining x is this one up here in the numerator. So we do have one more to take care of, so we'll go ahead and look at that one too. So step 4 says express x in terms of theta. But really you've already done that right here, so you can just go ahead and use that. So x would be equal to 5 times the sine of theta minus 4. So if you've done the previous step, you can use it. So now you also have the conversion for x. So inside these 3 boxes, you have the things that you need to change this from an x problem into a theta problem. So let's take a look at our next step. And the next step says, do that. Go ahead and rewrite the integral now in terms of theta. So what we'll do is, this is going to be step 5. So in step 5, you've got the integral of, and we'll put that right across here. Now, just take care of each part. X is equal to 5 times the sine of theta minus 4. So we'll go ahead and put that right here. So 5 times the sine of theta minus 4. The square root is equal to 5 times the cosine of theta. So this will be 5 times the cosine of theta. Then dx is equal to 5 times the cosine of theta d theta. So this will be 5 times the cosine of theta d theta. So what you've done, you've changed the whole thing from an x problem into a problem involving theta. And we'll put parentheses around this. Now again, if you can, simplify it, whatever you can. In this case, you've got a 5 in the numerator, 5 in the denominator. Those 5s will cancel out. You've got a cosine in the denominator or cosine in the numerator. Those cosines will cancel out. And so that will leave you with the integral of And actually, it's just going to be 5, let's go ahead and put it like this, 5 times the sine of theta minus 4, we'll put parentheses around that, d theta. Okay, now next step is to find the antiderivative of this. So if we look at step number 6, it says evaluate this new trig integral. So we'll go ahead and do that. And to do this, it's just a typical trig problem. Rather than having an integral of two things subtracted, go ahead and change it into two separate integrals. So we'll make this be equal to the integral, and we'll look at the first one. It'll be 5. We'll go ahead and move the 5 out in front. So 5 times the sine of theta, d theta. So there's the first one. And then you've got minus the integral of 4 d theta. So find the antiderivative of each one of those. This would be 5. And the antiderivative of the sine is the negative of the cosine. So this will turn into the negative of the cosine of theta. Then you'll have a negative. Now again, the antiderivative of 4 would just turn into 4 theta. So that'll become 4 theta. And then don't forget to tack on a plus c. Now, as we've done in previous problems, actually this is the answer, but it's in terms of theta. So you want to change it back into a problem in terms of x, and to do that, that's going to be these last two steps again. So we'll go back and look at our final steps, and step 7 says draw the triangle and label the sides, like we've done in the previous problems, and then use the triangle to write the final answer back in terms of x. So let's go ahead and do that. So first of all, just like we've done in all the previous ones, we'll make this be step 7, and just draw yourself a right triangle and label the sides. So here's the triangle. Here's angle theta. And if I were you, I'd take the time to go ahead and make this be. This would be the opposite side. This would be the adjacent side. And this is going to be the hypotenuse up here. So go ahead and take the time to label the sides. Now, two of the sides you're going to know from your trig functions in a previous part of the problem. So move back up here. And in this case, what we've got is this. X plus 4 is equal to 5 times the sine of theta. So we'll use that to find two of these sides. So we'll come down here, and you've got x plus 4 is equal to 5 times the sine of theta. We'll divide both sides by 5, and you'd have x plus 4 divided by 5 is equal to the sine of theta. But just a reminder, the sine of theta is the opposite over the hypotenuse. So in this case, that'll allow you to label two of your sides. So in our problem, the opposite side, the numerator, is x plus 4. So this side over here is going to be x plus 4. Now the denominator, the hypotenuse, is going to be 5. So this side right here will be 5. And then the remaining side, just like in those previous problems, will always be the original square root. So you can either write it in this form or you can write it in this form. I think I'll write it in this form. So this remaining side will be that original square root up here, which was the square root of 25 minus x plus 4 squared. So now you've got all three sides of your triangle. Now with that, now you can use that to change these remaining trig functions back into theta again. So this will actually be step 8. So first of all, you've got the constant 5, and we'll move this negative out in front, so it'll be a negative 5. Then you've got the cosine. Well, to get the cosine, look at your triangle. Now the cosine of theta is the adjacent over the hypotenuse. So in our problem, the adjacent side would be the square root of 25 minus x plus 4 squared. There's the adjacent side, divided by the hypotenuse, which is 5. So the cosine of theta becomes this right here, and you can use this and put it over here. So this becomes the square root of 25 minus x plus 4 squared, there's the numerator, divided by the denominator, which is 5. Then you've got minus 4. Now you need theta. Well, you can use any one of these three trig functions to get theta, but in a way you've almost already got it done right here. If x plus 4 divided by 5 is equal to sine of theta, take the inverse sine of both sides, and you would get the inverse sine of x plus 4 divided by 5 is equal to theta. So all you're doing is using this and turning it into that. So take the inverse sine of both sides, and you've got what theta is equal to. So theta is equal to the inverse sine of x plus 4 divided by 5, and then you've still got the plus c sitting out here. So actually, this is an answer to the problem, but we can go one more step and clean it up just a little bit here. So in this problem, we'll move it down to here. Now, first of all, the 5s would cancel out here, so that would leave you with a negative of, then you'd have the square root. Now, you can leave it like this, or if you want to, you can go ahead and change it back into the original, which was 9 minus 8x minus x squared. I think we'll go ahead and do that. So this you can change into 9 minus 8x minus x squared. Remember, this and this are both exactly the same thing. Then you've got minus 4 times the inverse sine of x plus 4 divided by 5, and then tack on a plus c to account for the constant. So it'll look like that. So really the only difference between this and some of those previous problems we worked, again, you had to do a completing the square first on this. So just a reminder, the 0 step is to complete the square. We'll put a little box around this to change this into this form where you've got something squared plus or minus something squared. And then you can go ahead and apply the regular rules. So there's a final problem worked out with that involves completing the square with a negative x squared term instead of a positive. So there's another example of trig substitution that involves completing the square.